So today we're talking about something that is actually going to translate completely through the whole year, okay? So these topics that we're going to talk about, how you change a graph, move a graph, flip a graph, all of these things are going to apply to every equation that we graph all year long, okay? So these are considered the parent functions, meaning they're the original graph. Nothing's been done to them. They haven't been changed in size or moved around or anything like that. So the line y equals x, okay, is just a slope of 1 over 1, and then there's a y-intercept of 0. Okay, so y equals x is just a line. Looks like this. Okay. When we have y equals the absolute value of x, it ends up looking like a v. And when we graph these, we always go up 1 over 1 and up 1 over 1, both directions. And then we just draw a straight line through those. Okay, so we do need those points on there. And then the last one. Anyone remember what the name of this graph is going to be? And there's an x squared. Looks like a u. What's that called? A parabola. Okay, here are the dots that you need when you graph it. It always starts at the origin. You go up 1 over 1, just like the absolute value graph. But then to get your next set of points, you start at the vertex, you go out 2, and you go up 4. And what it's going to do is create this U shape like this. Okay, so that's the original picture for each of these graphs. Now, today's notes we're just talking about what we do to these graphs by changing some numbers in the equation. Okay, so the first thing we're going to talk about, what happens if you put a negative sign in front of your x's? What happens to the line?
Goes like this.
Yep. Okay, so instead of going uphill, it's going to go downhill. Okay, what do you think is going to happen to the v? It's going to flip upside down. So we still need the points. And the same thing will happen to your parabola. So we need the same 5 points. Still going to start at the origin here and go down 1 over 1 and then out 2, down 4. Looks like that. Okay, so we've learned the first thing already. If you have a negative sign right after your equal sign, it's going to flip your graph upside down from here until the end of the year. Anyone still need this? All right, let's talk about what happens if we have a number on the end. Okay, you add or subtract a number. Let's do the line right here. How would we graph y equals x plus 3? Okay, so we're going to have a y-intercept of 3, but then the slope stayed the same, so it looks like this. So what happened to this graph compared to the parent graph?
It went up by 3.
Yep, the whole thing shifted up 3 units. So the same thing is going to happen with the other two. Okay, now we have absolute value of x minus 2, so what happened? It moved down 2. So now the vertex of your graph moved down 2, these points moved down 2, and now your absolute value graph looks like this. Yes, you need all 3 dots. I need to know that they are there, and I'll explain why in a little bit. Okay, the last one, the parabola. It's going to have the same shape, but the whole thing shifted up 1. So we put a point here, 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 and here's the last set. So anytime you have a constant on the end where you've added or subtracted a number, that's just going to tell you where to shift up or down in all of the equations we learn all year. Okay, let's look at what happens when we have a plus or a minus a number with the x value. Okay, this one right here, I'll just show you, is going to look like this.
Shouldn't it be the opposite?
I like your comment. Shouldn't it be the opposite way? Okay. It doesn't have to do with the absolute value. It's the rule where whenever it's with the x value, it's the opposite direction on the x-axis that you think it should go. And I'll explain when we get to the equation why that is. But anytime it's with the x, whether it's absolute value like the first two or the parabola on the end, if it's positive, it goes to the left, and if it's a negative, it goes to the right. So this one right here is actually telling you to go left 1, and where are we going on this last one? Right 2. We still need all of our points. So far we know that a negative sign will flip it upside down. Numbers on the end shift up or down. Numbers with X shift it left or right. So let's summarize that right now. We're just going to draw arrows to this. So where does it actually flip it upside down? What tells you that? What part tells you if it's flipped upside down? This was the first thing we looked at on the first slide at the bottom.
Plus or minus.
Yes, right here. This tells you if it's going to be flipped upside down or not. So let's circle this. That's what that tells you. Okay, I've got the pluses and minuses already with right here, but what number, or what letter, sorry, what letter tells you if it moves left or right? Is it H or is it K? Yes, the easy way to remember it is if it's with X, that's the number that it moves along the X axis. Okay, so this right here. Now, the equation you'll see is minus. So the minus sign right here is why it's the opposite way that you think it should go. So if it is -3 right here minus a -3, it turns into positive. Okay, so it really was a -3, but we subtracted that value so that the sign changes. Okay, what about moving up and down? This number tells us that. Okay, so what's the only thing we haven't talked about yet? Yeah, what the A value would do to a graph. Okay, so that's what we're going to talk about right now. Questions so far? Okay. All right, so what does the number mean in front? Let's first talk about it with lines because we already know this part. Okay, it is something to do with the slope. So if we were going to graph this one, we would start at up 1, and then we would have up 4 over 1. And if we had this one, let's just do a quick sketch. We go down 3, we go up 1 over 2. So what we want to think about is the steepness of these lines, how steep they are. Which one is more steep? The first one would be harder to ski down, right? If you had some downhill skis on, it'd be more of a black diamond. Okay. This one over here would be like a bunny hill. This one is way more steep. This one is less steep. So what can we connect with that with what these numbers are? When is it going to be more steep and when is it going to be less steep? When the slope is a high number, or when A is a high number, it'll be more steep. Well, where's the cutoff? As far as when it's more steep, when it's greater than this number, and if it's less than this number, it'll be less steep. 1 is the cutoff. So if it's greater than 1, it's going to be steeper. If it's less than 1, like the 1/2 right there, it's going to be flattened out, less steep. Okay, so let's look at these two. Okay, we have an a value here of 2 and then a 1/4 over here on the right. Okay, so this is going to be what? More or less? More steep. Okay, so this is the parabola. It's not moved anywhere, so it's right at the center. Now, normally we plot our 5 points. When you have an a value, you don't plot points. You just over-exaggerate to me whether it's supposed to be more steep or less steep. So this one is more steep, which means that the parabola is going to shrink in and get skinnier, right? You want to make it harder to ski down if you were going to ski on it. So normally it's, I'm just going to put the dots here. Normally it would follow along that path, but we want it to be steeper than that. So when we graph it, we just want to make sure that you're showing me on your test that you know that this is supposed to be steeper because of this too. You don't plot points. Okay, it's just a sketch at this point. You're telling me I know that the 2 means more steep. Okay, over here. This is going to be what? Less steep. Okay, it's not moved anywhere, so we're starting at the origin. Okay, I'm just going to put these here for reference. Normally they would go through those points, but we want it to be even flatter, even easier to ski down than the original. It's going to be less steep, so it's going to be out like this. If you want to put the original points on there just as reference so that you're showing me, I know it has to be less steep or more steep, more power to you, that'd be great. But just make sure that it's obvious to me that you know that a 1/4 would make it less steep. Does that make sense? No plotting points. Okay, let's summarize everything we've looked at right here. Okay, so this flips it down. This moves it left and right. This moves up, down. And then big numbers make it more steep is the last one. Okay, so this is kind of your roadmap telling you what each of the numbers mean. Okay, one last thing. When you see this, when you see a negative sign inside with the x, let's think about what would happen. So when it was outside, it flipped the graph completely upside down, right? So it flipped over the y-axis. When it's inside with the x, it flips it over the x-axis. So what would that look like? It would look exactly the same, wouldn't it, if you flipped it over the y-axis? Sorry, I was saying those letters backwards before. Okay, so if this flipped over the y-axis, wouldn't it look exactly the same? Yeah, it's like a mirror image. Okay, so that doesn't change. What about with parabolas if you flipped it over the y-axis? And it's going to look the same. So if you see a negative sign in there, it's not going to change the graph at all. Questions?